so far, we've looked at financial instruments where either a lump sum is deposited or is taken out at the end of a time period. This isn't usually the case because most of us don't have $10,000 laying around that we can just invest all at once. It's much more common to make a regular scheduled payment or receive a regular scheduled payment from an account. And that's what we'll be looking at in the next two sections. Before we start working any problems, we do have a new formula to look at. And there will be several more in these next two sections. So I would suggest that you keep a formula sheet handy to write down these so that you can use them as you need them. Okay, here's our first formula. It says if x is a real number and n is a positive integer, then 1 plus x to the first plus x squared plus x cubed and so on up to x to the n minus 1 is equal to x to the n minus 1 over x minus 1. Notice that although these sound the same, this is x to the n minus 1 power. This is all exponent. Here is x to the n exponent minus 1. So make sure you distinguish between those two. Okay, this is a special case of a geometric series. Let's look at it with numbers. If I have 1 plus 5 plus 5 squared plus 5 cubed, and we're going to go up to 5 to the 6th power. So our 6 is n minus 1, which means that our n will be 7. So this is x to the, not x, 5. 5 to the 7th minus 1 over 7, I'm sorry, 5 minus 1. Okay, now you could do this in your calculator as long as this number doesn't get too big, but it's faster to use the formula. So let's look at this. 5 to the 7th minus 1 is 78,124. And 5 minus 1 is 4, which gives me a total of 19,351. Okay, and you could add up these terms and find out that it would be that amount. Okay, we will be talking about annuities in this section. And the definition of annuities is an account that's made of equal payments over equal time periods. Okay, the word annuity is related to the word annual because many annuities have that time period as a year. Let's look at an example. $1,500 is deposited at the end of each year for the next 6 years in a savings account, paying 8% interest compounded annually. Find the future value of this annuity. Well, if we draw a little timeline, and we've got 6 years, so this is year 1, 2, 3, 4, 5, and 6. And what happens here? At the end of year 1, we deposit $1,500. At the end of year 2, another $1,500, and so on. Okay, now I want to find the future value of this annuity. Well, this $1,500 that's deposited at the end of year 1 is going to earn the 8% interest for 1, 2, 3, 4, 5 years. So we're going to have 1,500 times 1.08 to the 5th power. Now this second payment is only going to earn interest for 4 years. So I'll have 1,500 times 1.08 to the 4th power. Okay, and I could go on and on with that. I'm going to have 1,500, 1.08 to the 3rd, 1,500, 1.08 squared, 1,500 times 1.08. That would be our 3rd, 4th, and 5th payments. And then a payment is made at the end of year 6, but it doesn't earn any interest. So we're just going to have a 1,500 at the end. So I could consolidate this by just taking the 1,500 out of each term. I'm going to have 1.08 to the 5th plus 1.08 to the 4th. And then there would be a plus 1 at the end for that last year that doesn't earn interest. Okay, now let's look at the algebraic fact that we had before. If I'm adding up all of these powers of 1.08, I could write that as the fraction 1.08 to the 6th minus 1 over 1.08 minus 1. And this gives us a total of $11,003.89. Pause the video now and work on checkpoint 1. Okay, this last example was a model for finding a formula for the future value of any annuity. Suppose that a payment of PMT dollars is deposited at the end of each period for n periods at an interest rate of I per period. Then the future value of the annuity can be found by using this procedure from example 1 with these replacements. Okay, the PMT was the $1,500. The interest was 0.088%. 1 plus the interest, of course, would be 1.08. And this annuity was for 6 years. And so, of course, n minus 1 would be 5. Now we can write this formula. Future value is equal to PMT, payment, times 1 plus I to the n power minus 1 divided by I, just like that. Let's look at another example now. A rookie player in the National Football League just signed his first 7-year contract. To prepare for his future, he deposits $350,000 at the end of each year for 7 years in an account paying 4.1% compounded annually. How much will he have on deposit after the 7 years? So we'll use our formula. Future value is equal to the payment, $350,000, $1.041, that's the 1 plus the interest. And we're doing this for 7 years, minus 1. And here we have 0.041. So this comes out to $2,772,807.59. Pause the video now and work on checkpoint 2. Okay. Most of us don't make as much money as professional football players, so depositing $350,000 a year really isn't practical for us. Let's look at an example with a more modest amount contributed. Allison opens a money market account at Silvergate Bank that in July 2016 offered a rate of 1.11%. Assume Allison contributes $950 a month to the account and that the interest rate stays at 1.11 compounded monthly for the next 10 years. So we've got a smaller amount. We also have a change in that she's contributing monthly and the interest is compounded monthly as well. So what will be the value of the account in 10 years? So we know that PMT is $950. Okay, the interest is going to be the interest rate divided by M, which in this case would be 12 because we're compounding monthly. And the interest rate was 0.0111. And the number of months in 10 years, so our N is 10 times 12, or 120. So the future value is equal to our payment, $950, times 1 plus 0.0111 divided by 12. And we're going to raise just this part to the 120th power, subtract 1, and underneath we'll have 0.0111 divided by 12. And this gives us a total of $120,508.87. Okay, this problem has another part. It says, suppose that after the 10 years, Allison was able to invest the proceeds of the account in a money market account that paid 1.24% interest compounded monthly. If she continues to deposit $950 a month into the new account, what would the total be after an additional 5 years? So after 10 years, she found an account that pays a little better than this one, the 1.11. So she's going to move her money over and continue to pay. Okay, so the payments continues at $950. And we're going to do two parts here. We're going to talk about this continuing part where the payment is continually added. And then we're also going to talk about the lump sum part where she takes her money from the old account and just transfers it to the new account. Okay, our new interest is 0.0124 divided by 12 still monthly. But this time the n is equal to 5 times 12 because we're only investing another 5 years, so another 60 months. So our calculation here is 950 times 1 plus 0.0124 divided by 12, and this taken to the 60th power minus 1 over 0.0124 over 12. And this is going to give us $58,772.78. Okay, so that's for the part where the new part where she's continuing to pay in the $950. So I'm going to hang on to that number. We've got 58,772.78. And now we're going to look at the part that she transferred from the old account. So here my future value is equal to 1 plus I over 12. And this is raised to the n times 12 power. So n times 12 here. And we know that this I was 0.0124 and n was 5 years. So I'm going to get 120,508. That's how much she got out of the first account. 87 cents times 1 plus 0.0124 over 12 to the 60th. So now this is $128,000 to $12.80. So this is how much she gets with the old account balance, just continuing to earn interest. So I'm going to add that to this new account, 128 to 12.80, which gives me a grand total of $186,985.58. So altogether, this is how much she has. She's pretty close to $200,000. Pause the video now and work on checkpoint 3. The next financial instrument we're going to look at is called a sinking fund. A sinking fund is very similar to a savings account in that regular payments are made into the account and the money is accumulated. In a sinking fund, the accumulation is usually intended for a specific purpose. For a company, that might mean replacing capital equipment, that they need or paying a debt that they know is coming due. So let's look at how a sinking fund works. A business sets up a sinking fund so that they will be able to pay off bonds it has issued when they mature. If it deposits $12,000 at the end of each quarter in an account that pays 5.2% interest compounded quarterly, how much will be in the sinking fund after 10 years? So we're going to be looking for a future value. And we know that the payment that's being made is $12,000. The interest is equal to the rate divided by the number of payments. So 0.052, and we're paying quarterly, so 4 times a year. And n is equal to 4 times 10, because we're doing this for 10 years. We'll just write that one as 40. And so our future value is equal to the payment times 1 plus 0.052 over 4 over, I'm sorry, I didn't finish this. This is to the 40th power minus 1. And this is 0.052 over 4. And so when we work this all out, let's put the 12,000 in here. And we get a future value of $624,369.81. Okay, we talked earlier about the fact that sometimes companies issue bonds as a way to get money that they need for building or expansion or some other project or obligation that they have. And then this sinking fund is used to pay off the original bond purchase plus the interest that was promised to the purchasers. Okay, so this is sinking fund to pay off bond. Let's look at another example. Okay, in this example, a firm borrows $6 million to build a small factory. The bank requires it to set up a $200,000 sinking fund to replace the roof after 15 years. Obviously, this factory is not in Texas where you get the insurance company to replace it. Certainly, at least every 15 years. If the firm's deposits earn 6% interest compounded annually, find the payment it should make at the end of each year into the sinking fund. Okay, so this time we know that the future value needs to be $200,000. Okay, we know that the time is going to be 15 years and it's compounded annually, so n is just equal to 15 and the interest is 6%, so 0.06. So this time we're going to write 200,000 equals the payment. We're trying to find out how much do I have to put aside every year. And this is going to be 1 plus 0.06 to the 15th power minus 1, and then divided by 0.06. So if I work everything inside the brackets, I end up with $200,000 is equal to the payment times 23.27597. So I'm going to divide by that amount. And my result is $8,592.55. So even though a new roof is going to cost $200,000, if they can just deposit a little under $8,600 every year for 15 years, they'll have the $200,000 when they need to replace the roof. So pause the video now and work on checkpoint 4. We're going to skip over example 6. The equation involved requires either a graphing calculator or a program called a TVM solver, both of which I'm not allowing you to use for this course. So we're moving on then to example 7, where we'll talk about an annuity due. The annuities we've looked at so far all had payments that were made at the end of the period. But for an annuity due, the payment is made at the beginning of the period. So, Jillian will make payments of $500 at the beginning of each quarter for 7 years into a money market account at East Boston Savings Bank, which in July 2016 offered a rate of 1.08%. If interest is compounded quarterly, find the future value of this annuity due. Okay, we have a new formula for annuity due. Future value is equal to PMT. Looks pretty similar so far, but we're going to use 1 plus I to the n plus 1 minus 1 over I minus PMT. So a little bit different. So we're going to subtract one payment at the end. So for Jillian's case, we have future value is equal to 500 times 1 plus, okay, it's 0.0108 divided by 4, since it's paid quarterly. And we're going to raise this to the 29th power. It's 7 years. Paid quarterly is 28 payments, but it's n plus 1. So 29 here, minus 1 over 0.0027. That's this amount, the 0.0108 divided by 4. And all that minus 500 is equal to $14,561.66. As you're working through these examples and checkpoints, I would strongly encourage you to do these calculations a piece at a time. If you try to put this in the calculator all at once, the chances of making a mistake are pretty good, and it's very difficult to find it again. And also, make sure you're working these problems where you can look up the answer. If you're not getting the correct answer, then you need to figure out what you're doing incorrectly before you move on to problems where you don't know the correct answer. Pause the video now and work on checkpoint 6. Our last example is an example of an individual person wanting to accumulate a particular amount of money within a particular amount of time. Let's look at this. Shen Wong plans to have a fixed amount from his paycheck directly deposited into an account that pays 5.5% interest compounded monthly. If he gets paid on the first day of the month and wants to accumulate $13,000 in the next 3.5 years, how much should he deposit each month? And just a comment on this, having your savings deposited by direct deposit is an excellent way to do it. That way it's gone before you ever get your paycheck, and it's not like you can go use it for something and then at the end say, oh, I don't have enough money for my savings plan. So get it deposited by direct deposit and you'll never miss it. So this time we don't know what the payment is. He wants to know how much. Okay. The interest is 5.5% and it's compounded monthly. And he's going to save for 3.5 years. So 12 months in a year, 3.5 times 12 gives us 42 months for this savings plan. And he wants the future value to be $13,000. Okay, this account looks like a good way to save up for a very nice down payment on a car. So let's see how this would work out. The payment is equal to, oh, let's not do that. We're going to just start with payment times 1 plus, our interest rate is 0.055 over 12. And we're going to raise this to the 43rd power. 42 months plus 1 is 43. Minus 1. And then down here we got 0.055 over 12. And then we subtract the payment again. And we want our answer to be 13,000. Okay, so I can take the payment out here. And I have 1 plus 0.055 over 12 to the 43rd power minus 1 over 0.055 over 12, and this whole thing minus 1, because I'm factoring out that payment. And when I do this calculation, my result should be 46.4103 equals $13,000. So then I'm going to divide by the 46.4103. And I find that Shen needs to make payments of $280 and 11 cents. Okay, so not really too terribly much to end up with $13,000 in 3.5 years. This is the end of this section. So when you've completed working through these problems and checkpoints, you should be ready to go on to your homework assignment.